Hello and welcome everyone to a new episode of Toby's Tech Bytes, your regular .NET Tech Snack, the place for the front end, the back end, and everything. Today, we want to continue our journey we started last time with the QR code generating stuff. This time we want to add a digital signature to the mix so we can prove the authenticity of the QR code and its contents. What we want to achieve looks like this. We want to be able to generate a public and a private key. We want to be able to enter some data like hello world, and we want to create a digital signature of the data that we can verify that the data matches the signature. So if someone tampers with the data, we see that this is no longer valid. And of course, should we generate a different public key, the verification is going to fail, even if I bring this back to the original state. Only with the correct public key, the validation is going to succeed. Okay, in order to achieve this, we want to extend our little Blazor solution. And when I started with this or thinking about this, I was kind of enthusiastic because I was thinking, great, I'm using Blazor, so I can use the system cryptography namespaces that .NET provides, and I can implement all this in pure .NET. But sadly, if you try so, you quickly see that the APIs in question aren't available when targeting Blazor. So it was necessary to fall back to JavaScript for providing the functionality, but luckily, as most things in the world exist in JavaScript, there is also an API for these public-private key stuff, and it's called Subtle Crypto. This is the name of the object that we are going to use. And as you see on the website, here is a disclaimer, and I repeat this. It's very hard to get cryptographic things right, and here we have a low-level API, and it's very easy to mess things up and don't have any security at all. So please see what you see here as educational content. Don't use it in your production environment as it is provided here. Always check back with security experts to make sure that everything you do is safe and sound. Having that said, what do we want from these crypto API? We want to be able to generate a key pair. We want to be able to sign data given the private key and the data, and we want to be able to verify a signature given the public key, the data, and the signature. In order to reduce the amount of typing needed, I'm going to copy and paste the code snippet in, and we will go into the detail as we go. So first thing is we want to generate a key pair. So we use the window crypto subtle object and the generate key method that it provides. The first parameter details the algorithm to use to generate the key. You can generate symmetric and asymmetric keys with the subtle API. The RSA OAEP algorithm is for asymmetric keys, so it's going to create a public key and a private key as a pair. The second parameter says that the key is exportable, which we will use in a second. And the third parameter describes what we wish to do with the key. In this case, we write encrypt and decrypt, which is basically not very relevant at the moment because we are not using this key pair object directly. Instead of using it directly, we are going to export it in order to be able to present it to our application. And that's why the exporting parameter must be set to true, because in the next step, we are going to use the export key method, and we export the public key and the private key, and we have to provide the format that we wish to use for our export. And in the last step, we convert this binary string to a base64 encoded ASCII string and return this to our application. The next thing we wish to do is we want to sign data, and the code for this looks like this. We pass in the private key as the base64 encoded version that we created in the create key method. And because it's the base 64 encoded representation, we need to convert it back into the actual key. This can be done using the import key method. Because we are importing the private key, we must match the same format that we used here. Again, we have to specify details of the algorithm that we wish to use. This time we don't need an exportable key because we won't export the imported key again. And we want to use this key to sign data. And the next step is the actual signing process. Therefore, we use the sign method, passing in the algorithm again, the key we want to use for signing the data, and then the properly encoded data itself. And the result is converted from a binary string to an base64 encoded ASCII string, and this is passed back to our application. And last but not least, in order to verify this signature, we have to import the public key using the format. We exported it beforehand. It doesn't need to be exportable, and we want to verify something with this key. So we use the verify method for this, detailing the algorithm, passing the public key that we want to use to validate the signature, passing in the signature, which we need to convert back, and passing the properly encoded data. And the verify method answers with a Boolean, so we can just return this to our application. And this is the whole JavaScript side of life when it comes to our goal for today. For sure, we have to add the script to our index.html so it's properly loaded. And the rest is Blazor then. And in order to spare me some typing, I'm going to copy and paste a lot of things again. For sure, I'm going to copy and paste the whole HTML structure. I'm going to detail this in a second. And in order to get rid of the red squigglies, I'm going to paste in a code block that contains the needed data structures. First, we need a key pair object into our Blazor solution that is able to capture what we get from the create key method. I already prepared this class. It's really nothing special about it. It is just a simple DTO class having a string for the public key and the private key. We just have to add the proper using in order to be able to use it, and we have to initialize it in order to not get null reference exceptions when rendering the UI. And then we have our buttons, and we can just generate the handlers for these. Okay. And this is basically the structure. There's the button for generating the key pair and two text areas to show the public key portion and the private key portion of it. Then we have input boxes for the data that we wish to sign and an input box for the actual signature. And then we have two buttons to sign and to verify the signature and a little checkbox that shows us if the validation process was successful or not. So now to implement the three methods that we need, we just have to call into our JavaScript function. So on the Blazor side of life, the whole thing is really very easy. What we need is actually, again, a way to call into the JavaScript code. So we need to import or inject the IJS runtime object. We again call it JS. That allows us to call into JavaScript code. And with that at hand, our methods are just wrappers that call into the respective JavaScript functions. They have to be actually async because we need to await the call. So the first call is calling the generate key pair method. The second thing is calling into the sign data method, passing the private key and the data. And the last step is to just call verify signature. Again, we have to make this async. And here we pass the public key and the data and the signature. And then we are actually already done. So if we start this, we should be able to validate that the things are working correctly. So here comes the browser. And as we can see, we can generate a key pair. We can enter some data. We can sign it. We can verify it. We can tamper with it and see that it doesn't. Validates again. And this is basically it. Being provided with this, you can use the signature on a data structure that you then convert into a QR code. And as long as you exchange the public key of the signing party first, you are able to validate as a receiver of a QR code that the contents haven't been changed and that it had been created by the actual holder of the corresponding private key. The takeaway is that I was hoping to achieve most of what I need to achieve in C#. At least this is the promise that Blazor gives us. But as we can see, this doesn't hold true for each use case that we have. I mean, maybe this is not the most mainstream use case at hand, but it shows that even when using Blazor, you won't be able to just use C# code to provide a web application. Even when using Blazor, you will always need to have some understanding of JavaScript and the APIs that are at hand there. And of course, you will have to think about how providing the JavaScript to the client and how to package it if you use NPM packages or not. So you won't get rid of JavaScript completely, but at least you can for sure write the actual business logic in C#, and this is a huge benefit after all. I hope you liked what you saw today, and maybe this is useful for you in your own projects. I will upload all the code to my GitHub repository, so you can just check the code out and see if it is of any use for you. If you like what you saw, I would be happy about some comments or questions. And I hope to see you next time on Toby's Tech Bytes. Thank you. Bye bye.